So, all right. Good afternoon, everybody. A warm welcome to all the audience. My name is Konstantin Hütepol. I'm product manager at Softing. I will guide you today through this seminar from our seminar series we do this summer and autumn. I have a colleague with me.
Hi, my name is Arda Kushulu. I'm product manager as well, and I will be answering your questions on the question tab that you can see on the right side. So if you have any questions, just ask them there. I will try to answer them during the presentation, and afterwards we're going to be answering them as well together.
Very good. All right. So yeah, the theme is DCRU and what's that? DCRU is around for a while already and becomes now a quite important measurement parameter. In this presentation, we're going to talk about the applications. Why do you need DCRU, and what DCRU is, and how do you measure that? So DCRU actually means direct current resistance unbalance measurement. That's quite a mouthful for a word for a DC resistance measurement, and it's quite a interesting measurement. What the agenda for today is, basically, first we're going to look at the applications for per PoE applications. We're going to look then at the impact on the cabling. Then we look at the impact on measurements, at standards around PoE and DC resistance unbalance. Once we've done that, we will look at how do we implement that in our cable certifier, the WireXpert series. And then a few tips, what else do you need to consider around DC resistance unbalance, and in that circumstance also a few useful features additionally from of the WireXpert series. Before we dive into techniques and technology, we look very quickly on who we are. Softing is a holding company. The headquarters are in Haar near Munich in Bavaria, Germany. We are founded in 1997. It's a public company since 2000. We are about 90 million euro turnover. We have around 400 employees, and we have local presence quite around the globe. I'll come to that in the next slide. Basically, we have three business units. The first one is automotive. They do diagnostics on car control or vehicle control systems. The other group is the industrial group. They basically develop hardware and software for industrial automation. So we are the IT networks business unit dealing with test and measurement products for structured cabling, basically. Okay. Well, our testers, we have a wide range of handheld test devices, starting on certification testers for copper and fiber cabling, speed qualifiers, wiring testers, and network test tools, tracing kits, gigabit Ethernet network analyzers, and also wireless LAN products. So that's enough for commercial things. We are based worldwide, as I said. We have quite a few locations in Europe: Munich, Vienna, Milano, Paris, London. We have an office in Shanghai. Our development of our products, most of them are developed in Singapore. And we also have a strong US presence in Knoxville, Tennessee. That's about Softing. So now let's look at applications. Let's look at the techniques. Why do we need all these new things? One driver for new measurements for the DCRU measurement is PoE lighting. PoE lighting has a lot of huge advantages against normal lighting, normal cabling for lighting. One is you have a generic cabling. You can use the same cables for Wi-Fi, camera, sensors, lighting, building automation, Ethernet. It's all the same cable. It's low voltage, so it's increased safety. You can touch PoE wires, bare wires, without any safety issues for users. I wouldn't do that with power cable, mains cable. So, and PoE lighting is easy to control in the Ethernet ecosystem. Every PoE light has an IP address, so it's an IP device in an IP network. And a very big advantage also is the overall reduction of the energy consumption. If you do that, central PoE power supply has a much better carbon footprint than actually if you have all kinds of different power supplies. That's one big driver for PoE. Other drivers are high speed and high power access points, cameras. You can say, okay, cameras have, there are IP cameras with PoE around for a long time. But if you look at, for example, at cameras for outdoor use, they need heating systems, built-in heating systems. So usually they have a separate power supply just for the heater. If you can supply enough power via PoE, so via the Ethernet cable, you can save the extra power cables. And in future also workstations, laptops, monitors, TVs, all these devices, they should be powered with PoE. Standards around PoE, PoE is around since quite a while already, since 2003. 802.3 AF was the original PoE with a maximum power of 15.4 watts at the switch. You always have to differentiate between power at the switch and power at the device. So in this table, you also only see the power at the switch, basically. Then in 2009, 802.3 AT was developed, so-called PoE Plus. That was already 30 watts. And just 2 years ago, 802.3 BT was developed, so-called 4-pair PoE or high power PoE. Some people also call it PoE++, with up to 90 watts. So that's quite a lot of current, quite a lot of power. You try to shoot down a thin Ethernet cable. That has some effects on the cable. One effect is you are almost sending 2 amps of DC current through an Ethernet cable. That will heat up the cable. Cable heating is influenced by the wire diameter, by bundle sizes, distance between cables, and this sheer cable construction. So if you look at such a bundle here, the center of the bundle will just heat up. And you can imagine if you have long trays of cables like you see here on the bottom left, there will be quite a lot of heat there. Other things is also connections heat up. The contact materials, aging of connectors, corrosion, humidity, dust, all these things contribute to higher resistance at connectors, and this contributes to heat. Other effects are installation issues. The increase of the DC resistance can come from poor connector termination. So if you see a connector like here on the top right, I wouldn't necessarily try to use 4-pair PoE in such a connector. Or if you have too high pulling forces, like if you have people pulling the cable like this gentleman here, you can imagine that this does some harm to the cable and also will have an influence on the DC resistance. Also disconnecting from PoE brings up issues. Basically disconnecting under power destroys the contact surfaces. So you see like the contact surfaces inside a socket, they will have burned faces over time. Connecting is not a problem because in the connection process, the PoE switch only delivers very low power. But once the devices are booted up, the PoE switch basically cranks up the power to the required power level. And then if you then disconnect, there will be a spark between the socket and the plug, basically. And that basically destroys the connectors like you can see here. So if you look at the effects on heating on cables, I've copied this table from ISO IC 29125. That is basically installation instructions that gives you guidance on cable bundles and temperature increase in cable bundles. So the left column here is the number of cables. You see 1 up to 91 cables. And then it gives you guidance for different categories of cables, how warm they can become. For example, here a category 6 cable in conduit becomes 22 degrees warmer than ambient temperature. So imagine in summer, if the building is about 30 degrees warm, your cable becomes 52 degrees warm. Or good category 6A cable in conduit is 17.9 degrees. So you can see there's quite some heating going on in cables. Increased heating will age cables, and keep in mind cables can also, all cables have a maximum rated temperature, usually 60 degrees Celsius. So you get quite close to the maximum temperature rating of your cable. So what do we actually then need to measure? Our testers, cabling certifiers, they don't measure PoE really. We have other testers that do that. For example, cable qualifiers, they measure real PoE. What we do is, on cable certifiers, is we measure the passive properties of a cable. And for the older PoE applications, like the 15 watt or 30 watts, it was sufficient to measure the DC loop resistance. You had an ohm, basically our certifier has an ohm meter at the local end, and the remote end just did a shortcut here. So, and the tester was only measuring the loop resistance of these two wires. For 4-pair PoE up to 90 watts, this is not good enough anymore. We need new measurement methods to find out if the individual wires heat up too much. And if you use that high power on cables, the individual resistance of each wire becomes important. Imagine if the blue wire here is warmer, has a higher resistance than the white wire here, the blue wire will heat up much more than the white wire. And wiring actually means everything. I mean, cables, connectors, patch cables, everything will heat up. So we need new measurements, and these famous DC resistance unbalance measurements, DCRU. Unbalance basically is asymmetry. So one measurement we need to do is the DC resistance unbalance between pairs, or DCRU P2P, pair to pair. It's basically just comparing the loop resistance of all pairs. Same thing here. If, for example, the upper pair has a higher resistance than the lower pair here, the upper pair will heat up more than the other one. So you need to compare these two and make sure that the DC loop resistance of both is very, very similar. This is an easy measurement because all the old legacy certifiers can do that as well. The more difficult one is DC resistance unbalance in pair. In that measurement, we measure only the resistance of a single wire. So in this picture here on the bottom, we only measure the resistance of the white wire. For laboratory environment, that's really easy because the ends of the cable are on the same desk. You just need to connect a tester to both ends that are on the same table, and you can measure. In a building, that's more difficult because in a building, these two ends can be up to 100 meters away from each other. So that's quite a challenging measurement. All that and the accuracies for that are defined in IC 61935-1-2 and since I believe 2018. And so we have a foundation how to measure those things. But this standard is only the measurement standard that defines how to measure. The limits are somewhere else. The limits actually are in the cabling standards. And the cabling standards, you have to differentiate. None of the cabling standards today calls that measurement a normative measurement. Normative would be you must measure it with a pass-fail. Standards today differentiate between an optional measurement. Optional means you can decide if you want to measure it. If you decide to measure it, it is a pass-fail criteria. And informative measurements. Informative means you can measure it if you want to, but there's no limit. For example, that has always been the case for length measurement in ISO. ISO is always measured length, but not with a pass-fail. Different like in TIA. In TIA, length is a pass-fail criteria. So if you look at it, at one of our famous ones here is the ISO 11801 class D up to class 2. Class 2 is category 8.2, for example. DC resistance unbalance is an optional measurement. Both are optional measurements. Different, like in TIA, for example, TIA channel measurement is just an informative measurement. So in standards, you also see a different term sometimes called reference conformance testing and installation conformance testing. I also mentioned that because people sometimes don't understand the difference between those terms. And reference conformance test is a laboratory test. So manufacturers can do this reference conformance test once in a laboratory to show that their product is conforming standards. What we do with our testers in the field is installation conformance testing. And you can also see here, DC current, DC loop resistance test and the DC resistance unbalance test in ISO 11801 is a normative measurement in the laboratory. So each manufacturer nowadays have to prove performance in the laboratory once. And the loop resistance measurement is a normative measurement in the field and an optional measurement in testers in the field. So optional, why do they make that measurement an optional measurement? Because you actually only need that if you plan to run high power PoE applications. Beyond 60 watt, you should make that measurement. So since not all the links in a building will need to run these high powers, it doesn't make sense to make it a normative measurement. So installers should take care and make sure if the final customer actually plans to run 4P PoE applications. If so, they should make that measurement. So far, so good. So how did we actually do that, or do we do that in the WireXpert series? In the WireXpert series, we have designed new test adapters for permanent link and channel measurements. And obviously, we also need new menus and a new version of the PC software export for our certifiers. Why do we do new adapters? Well, the original WireXpert was not capable of that measurement, so we designed new adapters that has an advantage for users. It's an optional parameter, so you don't really need these adapters if you don't plan to use that application. And all the existing WireXperts in the field, right from the beginning of these product series, they can all be retrofitted with these new adapters. So new adapters, new software, you're good to go. It's very easy. How does that measurement, is that measurement activated? Basically, the DCRU tests are obviously only available if you have the right adapters for the tester. And you only need to activate those DCRU tests once in the test options. So from the main menu, you go to test options, and then you go to DCRU and activate those. And the tester decides by itself, by the standard that is used, if DCRU is an optional measurement, so with pass-fail criteria, or an informative measurement, so without pass-fail criteria. You don't need to select different standards. Like in this example here, this is the classical ISO class EA channel measurement, and the tester by itself then knows, okay, in class EA channel, if DCRU is activated, it's an optional measurement, so I need to apply pass-fail limits. There's no need for new standards, so it's actually very easy to use. How does it look like in a tester? So once you run an auto test, you get this overview screen here with the worst case values, and you just have a couple more worst case values here: DCRU pair-to-pair and DCRU in-pair. If you then look into details, you first get the loop measurement. So that's the good old DC loop measurement here. And you get the DCRU pair-to-pair and DCRU in-pair measurement. What's very interesting here is if you compare the limits, this is isoclass EA limits. Isoclass EA loop limits is 25 ohms. The DCRU pair-to-pair is 0.2 ohm or 7%. 7% in percent means percent of the average value. So there can be only 0.2 dB difference between all the pairs or 7% difference. That's milliohms here. That's a really tough measurement. Same or even worse actually in DCRU in pair, you also have 0.2 ohm and 3% only. That's very tough. So if you then go, for example, go and measure really old legacy cable and try to measure DCRU on an old legacy cable, there's quite a good chance that you will fail because these limits are really, really tough. Okay, further, in the DCRU software, in the export software, DCRU is just a couple more tables here with all the values, and here, for example, is an example for a failing measurement. And in the PC reports, the PDF reports, we only by standard are required to show the worst case values for each, like on crosstalk and insertion loss as well. We only show the worst case values here. That's basically how we report that. What else should be considered? There's a couple of things you should note about PoE and be careful with this. If you look at 4-pair PoE, 90 watts at 48 volts means 71 watts at the socket is 2 amps of current you push down a category cable, or 0.5 amps per wire. That's quite a lot for a thin wire. The DC resistance of a wire highly depends on the wire diameter. If you look at this table here on the left, that's most of you probably know the AWG is the wire gauge diameter. The smaller the value, the bigger the diameter. You can see the diameter here on the right side as well. So the dark one is the diameter. So here you can follow the diameter, and the light one is the DC resistance per ohm per kilometer. So you can see the higher the wire diameter, the smaller the resistance, and you can see how drastically the resistance goes up with smaller wire diameters. So the wire diameter is an issue. The patch cord connectors wear, the sockets in patch cords wear, the plugs wear. So the DC resistance unbalance actually also heavily depends on wear. And the patch cords basically have the thinnest wire diameter in a link. So actually the patch cord is the weakest link, symbolized here. Sorry, whoops. Symbolized here with this bracket here, is the weakest link in the whole thing. So if you run into DC resistance unbalance applications, means 4-pair PO applications in installed cables, it actually makes more sense to measure channels than permanent links, because patch cables are the weakest link. If you install new cabling as an installer, you're most interested in the permanent link, because that's basically your installed goods you sell. If you are more interested as a owner of the cabling system, you should watch the channel measurements, because the channel, as I tried to mention here, the patch cords in the channel is the weakest part of the whole thing. So what else should we consider? Wear and dirt. Wear and dirt. Keep in mind, DC resistance unbalanced values are in the milliohm range. Remember 2 slides or a few slides before, 200 milliohms in ISO IC is the limit line. So dirt and wear on the connector actually has an impact on DC resistance unbalance. It can cause high readings or unstable results. If you look at this connector here on the right, you see that there's some dirt on this connector here, on this pin here. That can also already fail a cable. And Why does it wear and dirt can cause unstable results? If you connect several times, you might hit different points on the connector, you know, on the socket and on the pins of the RJ45. So that can have an impact on the measurement. DC resistance unbalance errors even can occur on good cables, good category 6A material, if that was not used for a long time, because there might be dirt or actually corrosion on the connectors. This is a small example here. If the pin of the RJ45 and the pin of the socket, if they hit a good spot, you might get a good reading. If they hit a slightly dirty spot, you get maybe a marginal reading. And if you hit a more dirty spot on your connector, you might get a fail. So that can happen in the field. That brings us to troubleshooting. So what do you actually do if you have a DC resistance unbalance fail in the field? There are a certain number of steps you can look at and trying to actually repair the problem. First of all, make sure that the material is approved for DC resistance unbalance and 4-pair PoE. Keep in mind, the standard in IEEE is only 2 years old now. So if you have cabling that is maybe 5 or 10 years old, it might actually not be capable of running 4-pair PoE. The second is you can try to reconnect several times. Reconnecting brushes off dirt from connectors. So it actually cleans the contact zones. That can actually already help. If that doesn't help, you can try and clean the RJ45 plugs. You might think, now, I'm not in a fiber seminar right now. Usually we clean fibers, but actually in RJ45, it starts to make sense to try and clean connectors. That's really strange, but that's the case. You should try something dry and lint-free, like a Q-tip or so. You can use a little bit of alcohol or tuner spray, but don't spray anything into RJ45 sockets, and don't use spray that contains oily agents, because oil leaves residues and basically dust and dirt starts to stick on that. The RJ45 plug contacts are actually difficult to reach, so make sure that you really clean the contacts and not just the plastic. If that doesn't help, use new patch cords. Buy quality category 6A patch cords, for example, good wire diameter, and try again. If that doesn't help, try and terminate new sockets, because if the sockets are maybe already a few years old, they might actually be not good enough. If all that doesn't help, then that's really bad news. You have to install new cabling, because then the cabling is just not up to speed for that application. So I hope this few hints helped you. That's all about troubleshooting and DC resistance unbalance so far. I have a few other interesting things I would like to show you on what else you can do with the new adapters for the WireExpert series. One is if you use screen cables, we have implemented screen integrity tests. But, there are no clear specifications and standards actually how to measure that. What we try to do is, if you have a screen cable, you have basically a ground connection between your outlet and your patch panel through the cable, but also through the building ground. So you have two paths of ground. If you actually do not connect the shield of the two cables or one cable, you still have the ground connection through the building. So a cheap wire mapper basically cannot detect that. A cheap wire mapper will give you a pass because it sees that ground connection. So the new adapters basically can differentiate, is the ground connected through the building earth or through the shield. And in some regions in Europe, the double outlets are quite popular. So there's another problem here. If you have two shielded cables connected, like in this example, and only one shield, let's say the shield of the upper cable is connected and the shield of the lower cable is not connected, normal testers will not find that problem because there is a ground connection. But our tester with these new adapters actually can differentiate also if both cables are connected. How do we show that problem or if there's a shield integrity test problem? It's actually very simple. We just say shield open at the local, for example. So it says it also depends a little bit how long the cable is. If you have very short cables, a tester cannot differentiate anymore between the local and the remote. But if the cable is a little bit longer, you can say the tester will say open at the local or open at the remote. Right, that brings me to the end of the seminar. I would like to draw your attention to our other seminars. We have quite a number of online seminars around topics, basics of cabling, copper fiber, product-related training seminars on specific products. We have technology presentations like this one. We have a next one coming up on Thursday on single pair Ethernet, for example, also an interesting topic. We just recently had one about just PoE from a PoE technology point of view. This presentation was already done, but you can view it on our website still. And we also have standards updates that brings you up to date on latest standards. On the bottom here, you see the link how you can register for these seminars. Also, just a small commercial at the end. We have a nice autumn-winter promotion. Take a look at our website. Maybe you find something interesting there. That's basically it. Now, we had questions, Ada, I believe.
Yes.
Yes, Ada will bring up the questions now we had, and we'll try to answer your questions. And you can also, while we talk, you can still post questions, and we'll bring them up.
Exactly. So let's start with the first question. Does it make sense to measure DCRU just on one cable, or should I measure all the bundle?
Okay. Basically, there's two aspects. In bundles, there's this additional problem with heat, because cable heating becomes more and more problem the bigger the bundles are. But there's also the problem if one link by itself can support 4-pair PoE. So yes, it makes sense just to measure one link if you just want to run 4-pair PoE on that one link.
Okay. So the second question, does the result say which standard of PoE would the cable actually support?
Well, yes and no, because if you pass the limits in ISO or EN standards, for example, it will support all the PoE applications, but it doesn't differentiate between the power classes, for example. If you pass DC resistance unbalanced, all the PoE applications will work.
All right. Okay. So third question, do I have to test DCRU each time when I certify a cable?
Not necessarily. We basically recommend, or it's also in standards basically, that it's an optional measurement, and you should do this optional measurement if you plan to run high power PoE applications higher than 60 watt. So in that case, it does make sense. If you never plan to run PoE, then you shouldn't care about it, and it's pointless to measure it.
Okay. Would you like to say something?
No, yeah. I mean, the DC loop resistance measurement, the normal DC loop resistance measurement is also very helpful to see issues around aging and so on. So it's always good and this is a normative measurement, but the DC resistance unbalance actually only makes sense if you plan to run 4-pair PoE.
Okay. We have one product-related question. What model of tester do you recommend for a CCTV installer?
CCTV.
Yes.
CCTV is the good old. I mean, it depends. Real CCTV is on coaxial cables. So coaxial cables, they run real CCTV cameras on coaxial cables. They run an analog signal. In that case, I would recommend a WireExpert 4500 because of high frequency range. If you also mean with CCTV, actually IP cameras, IP cameras, they only need basically today's IP cameras only basically need 1 gigabit bandwidth cables, which basically means Class D cables. So actually ISO recommends now to install category 6A cables, but basically for these applications, the WireExpert 500 with 500 megahertz frequency range is enough.
Yes, so you just added another question, saying that not question, but comment CCTV installer for IP cameras with CAT cable.
Yeah, okay, exactly. CAT cables. Well, in that application, the maximum you need is category 6A cables, and the 500 is the perfect tool for that.
Yeah. So maybe also another tester to test PoE if there is like for IP camera installer, right?
Yes, if you are really interested in, that's a very good point. If you're really interested in PoE measurements, if a PoE class actually can be supplied by a link, you cannot do that with a WireExpert because they only care about the passive cable. For this purpose, we have different testers, like for example our NetExpert series, where Ada is the product manager for those testers. These testers actually really test if PoE works. They apply load tool cables and give you feedback which classes are available in those things. Yeah. So that's more from an application point of view tester.
Yeah, I mean the question is actually there if the camera installer need a standard or not. If they don't need a standard, then NetExpert XG would actually see if the cable is supporting up to 1G, and then at the same time would test also if there's a PoE also supported on that link.
Right. This is also quite useful for troubleshooting. If you install, for example, an IP camera, which is PoE driven, and the IP camera doesn't boot up.
Yeah.
You can test if the cable works, and you can test if the switch actually supplies the right power levels.
Yeah. So another question.
Cool.
I want to learn target customer like M12D codec, target sectors with specific adapters.
Targets for M12 connectors.
D codec.
The M12 is mainly used in industrial environment, and the M12D coded is the industrial connector for applications like Profinet, for example. There are also some IP cameras that use the M12, outdoor IP cameras that use the M12 connector. We have test options for the WireExpert series to test M12D or X-coded industrial connectors. And we can also, with adapter cables, do that measurement with the NetExpert, for example.
So a question, if we are sending all presentations via email, I think they're already, you can already download them.
Yes, you should see in the little taskbar you have, you should see a little documents, and there are documents for download. And there's a little questionnaire that will come up at the end of the presentation. It only takes a minute or so. We would really appreciate if you can go through that questionnaire really quick. It's only a few questions, and you don't have to buy a washing machine afterwards. So it's very simple. All right.
Yeah, and the videos will be uploaded later as well on the website. So
correct.
Yeah.
Videos will be there.
Okay.
That's all?
Yes.
So thank you for the time. Thanks for joining the webinar. Stay tuned. Take a look at our website for the additional webinars we offer. And I hope to see you soon again. Thank you.
Thank
Goodbye.
You. Bye.